And we are working on chapter 2, linear equations in two variables. Today we're going to see parallel and perpendicular lines. If you remember last week, we learned how to work with slopes, and we're talking about slopes of a ramp, slopes of a stairs, slope of a ladder, and also slope of linear equations, which is always going to be rise over run. Right? Don't forget this, rise over run, very important. And yesterday we actually learned a new formula to find the slope of a line. It's going to be y2 minus y1 over x2 minus x1. This is a new formula. At the end, this is going to be also rise over run. But this is a new formula that if you have the coordinates of 2 points in the line, you can find the slope. Great! Now let's apply this knowledge to today's topic, that is parallel lines and perpendicular lines. I suppose you all know what is the concept of parallel lines, right? If you have two lines, that they are running side by side. They don't have an intersection point. They never intersect each other. They're going to be parallel lines. Two parallel lines, two lines that never intersect each other, and they run side by side. And perpendicular lines, I think also is something that you already know. You already understand the concept of perpendicular. You have here two perpendicular lines. They have one intersection, and they actually have an angle between them of 90 degrees, the right angle, and that means they are perpendicular lines. And we know how to identify, if we look at the picture, right? You look at the picture for parallel lines, we can identify they are parallel. You look at the picture of perpendicular lines, yes, I can see they are perpendicular. And actually what we will see today, what's different, that we will learn how to apply and how to do, is to identify if it's a parallel line or if it's a perpendicular line, not by looking at the picture or the drawing, but by comparing the slope. We're going to compare the slope. And by doing this, we will be able, just by comparing the numbers, we will be able to say that if the lines are parallel or the lines are perpendicular. Okay. Next slide for the definition, the properties. If lines are parallel, and you're going to have the slope of line 1, the slope of line 2, you're going to realize that both slopes have the same value. They are equal. They are represented by the same number. So if the lines are parallel, the slope is going to be equal for both lines. Okay? Next property, if the lines are perpendicular. Well, if the lines are perpendicular, each one is going to have a slope, m1 and m2, different from 0. Good morning, Serenity. And actually, what you're going to remember is this property here. If you multiply slope of line 1 by slope of line 2, and we get -1, this means line 1 is perpendicular to line 2. This is the property that defines, that makes you realize that line 1 and line 2 are perpendicular. If you multiply these slopes, then you find out -1 as a result. Okay? This concept, I think, is pretty straightforward, pretty simple. But when we apply, we need to work out a few calculations, and sometimes can be a little bit hard, because you need to be really careful to not making any mistakes, especially if the signs. I'm going to show the example. Real quick, going back to the pictures, let's compare. Parallel lines. Can you see parallel lines? Compare the slopes. M1 equals 5 over 3, M2 equals 5 over 3. So they are the same, they have the same value, they are parallel. Perpendicular lines. Here we can see they are perpendicular. The slope of the line 1 is negative 7 over 2. And the slope of line 2 here is 2 over 7. If you multiply negative 7 over 2, you can simplify here, times 2 over 7, you will have negative 1. That means those lines are perpendicular. Let's see how to work out an example. Determining whether two lines are parallel, perpendicular, or neither. So 2 points are given. For each line, you have line 1 and line 2. And each one is going to have 2 points. Let's say point 1 here and point 2 there. Without graphing, determine if the lines are parallel, perpendicular, or neither. So let's work. And the first thing that we need to do is to apply the formula of the slope formula. y2 minus y1 over x2 minus x1. And let's apply to the first line. So this is going to be M1, okay, first line. y2 in the first line, check the first line, only the first line, not the second line yet. First line. y2, 1 minus y1, negative 3, over x2, 4, minus x1, 2. Then you can find it 1 minus negative 3, 4. 4 minus 2, 2. This is going to be 2. Okay, this is the slope of line 1. Now we're going to work on the line 2, slope of line 2, okay? Slope of line 2. So M2, let's check the data only of line 2. Forget about line 1 now. Let's go over only line 2. y2 here on line 2 is negative 2. Minus y1, negative 6, minus negative 6. Over x2, negative 3, minus 5. 5 is x1. Negative 2 minus negative 6, negative and negative positive, negative 2 plus 6, positive 4. Over negative 3 minus 5, negative 8. And this is negative, if you simplify, right, negative 1 over 2. What do you think? Are the slopes equal? No, they are different, right? So the lines are not parallel. If you multiply both slopes, what are you going to find? Let's multiply 2 by negative 1 over 2. And you find negative 1 as a result. So is negative 1 the result of the multiplication? Yes. That means the lines are perpendicular. Those lines here are perpendicular. Questions so far? See, the concept is not difficult, but there's some work here, some hard work. You have to do some calculation, and you have to be careful to not make any mistake on the sign. If you make any mistakes, you're going to find out the wrong answer. See? What do you think? Feedback. Is it difficult, confusing, or is it a bit confusing? Serenity is giving a feedback. I'm a bit confused on how you determined that it was perpendicular. Yes, perpendicular. You have to multiply M1. Let me move this a little bit up so we have more space. just a little bit up. Okay. And okay. Right. To find out if it is perpendicular, we found M1, and we have to multiply by M2. We have to multiply by M2. If the result is a -1, that means they are perpendicular. So M1 is equal to 2 times M2 is -1 over 2. If you multiply 2 times -1 over 2, simplify, positive and negative, negative, this will result -1. Every time you find this as a result, -1, that means the lines are perpendicular. Thank you, Jacob. Thank you for the feedback. Thank you, Serenity. Thank you, Jermaine. And we're going to work on the quiz and a few examples. Maybe you will understand how to work out this. But basically, if they are not, you just eliminate parallel, right? Because they are not equal. Now you check if they are perpendicular. Before we start the quiz, just a quick thing I want to show you from the slide is about applications and interpretation of slope. And there's another thing that we're going to work on the quiz, the second part. Slope of a line has lots of applications and usually is connected or is related to rate of change. And if you find on a question asking about rate of change, rate of growth, rate of increase, rate of decrease, anything like that, if it's a linear change, then we are talking about slope of a line. And we will be calculating using slope equals m equals rise over run, and also we'll be able to use the formula that we learned yesterday, y2 minus y1 over x2 minus x1. So don't be scared if you find an application question with a lot of data and graph and a lot of information. Most of the time, if there's an application of slope at the end, the only thing that you need to know, you need to apply, is the slope formula, is the rise over run concept. Okay? Let's try see y2 minus 3.75 equals to 0.85 and y2 equals $3.75 plus 85 cents. Okay, Julian, no worries. That means y2 is equal to 4.60 cents. 4.60 cents. This is going to be the answer. The answer for this bell work. 4.60 cents. $3.75 is here. Okay, Kalia, is the price of the ice cream in 2010. And let me see who got closer. Adrian got closer, Gabriela 450, yes, close. Maddie close, Angelique close, 450. Makina pretty close, Valeria is pretty close as well, Valeria. And Talia 450. Jacob 450. Jermaine 450, Adrian 450. Nobody got 460, but most of you, at least half, more than half, actually found 450, very close for 460. The answer is going to be 460. This is the hard way, the way of calculating the answer by using the formula and doing all the calculations, all the step by step. But a little secret here, I'm going to show you a very easy way. Okay, this is the the normal way, the hard way maybe, because you're going to apply the formula and you realize the slopes are the same. But check it out. I'm going to clear this and show you the easy way. Look, the lines are parallel, right? Parallel lines. If the lines are parallel, this distance here is the same as this, the distance right up here. This is going to be the same. And you're going to find this distance by subtracting 4.25 minus 3.75 is 50 cents. 50 cents, right? So here is also 50 cents. But this point is where the price is 5.10. To find out this point underneath, you just need to subtract 50 cents from 5.10. So 5.10 minus 50 cents, 4.60. And this is the right answer. See, this is an easy way to find out. If the lines are parallel, you can visualize, you can actually find the answer much quicker by interpreting and realizing the distances here, just interpreting and understanding the graph. So the answer is 4.60. Thank you. Great. Move to the quiz, okay? And we still have plenty of time to work the quiz, I think. Yes. Yes, we have a lot of time to work the quiz. And today the quiz, I'm not gonna say it's difficult. I'm just gonna say it has some hard work at the very beginning, in the first part, okay? It's not difficult, but some hard work on this first part. Let me give you the example here on letter A. We have 2 points in the first part of the quiz. 2 points are given for each of the two lines, L1 and L2. Determine if the lines are parallel, perpendicular, or neither. So let's check here, letter A. We need to calculate M1. Let me zoom in. We're going to calculate M1 and M2. And then we're going to compare. Let's say this is point 1 and point 2. Okay? And the formula is the same, y2 minus y1 over x2 minus x1. y2 minus y1 over x2 minus x1. When we're calculating M1, we're gonna use the data only from line 1. Just be sure don't mix up. So only from line 1. y2 is 9 minus y1 is 5, x2 is 4 minus x1 is 2. And this is going to be 4 over 2. Right? Now let's check M2. And when we're working on M2, make sure you look only at the data from line 2 here. So let's find y2 is going to be 2, y1 4, x2 3, x1 negative 1. 2 minus 4 negative 2 over 3 minus negative 1 4. This is negative 1 over 2. So let me ask you, are the lines parallel? Are the lines parallel? Are the slopes equal? M1 is M1 equal to M2? Check it out here. M1 is 2 and M2 is negative 1 over 2. So they are not equal, right? And Jacob got it right, yes. If you multiply them, multiply 2 by -1/2, you find -1. That means the lines are perpendicular. Perpendicular. They aren't equal. That's right, Ewell. They aren't equal, so you can eliminate parallel. You can cross out parallel. It's not going to be parallel. But if I multiply both numbers, you're going to find -1. That means, yes, they're going to be perpendicular. Okay? So this is how we're going to work on the next questions, B, C, D, E, and F. And I know it's hard work. At the end, the last couple of minutes, I'm going to give you the answers for these questions here, so you can compare with your answers. Let me show real quick about this, the second part. And the second part looks hard, looks difficult, because you have a lot of data, you have a lot of information, but actually what's important here on the second part is that you have the points, 2 points, and you're going to call here point 1 and point 2, point 1 and point 2, and you apply the formula m equals y2 minus y1 over x2 minus x1, and that's it. Because here we are trying to find the rate of growth, or over there, rate of increase, or rate of change. Everything is actually a different name, another name for slope. So it's another way of applying this formula here, another way of calling, of naming this formula. Right? Let me give you a couple of minutes to work this quiz, and if you need help, you type in the chat box. If you